All right, so welcome to the session. Thank you guys for staying, getting close to the end of time. I know it's later in the afternoon, so hopefully this will energize you to get you through the rest of the evening. My name is Jennifer Reif. We do have quite a bit of content we're covering in this 50 minutes, but please do feel free to catch me after the session, or feel free to reach out to me on Twitter or email or whatever you're most comfortable connecting with me on. I'm happy to answer questions or dive into topics afterward. And then, of course, I'll be roaming the halls, so feel free to catch me then as well. I'm a developer relations engineer for Neo4j. I really enjoy learning about development topics, new technologies, as well as very standard and excellent technologies. And then I enjoy blogging about it and coming out and speaking at conferences. So I'm really thrilled to be here. I'm glad I was able to get accepted here. And my cats loaned me out for the week. So I'm sure they're missing me at home. They help me code and write while I'm home, so they're down here in the bottom sitting at my desk going, why are you trying to do anything but pet us and pay attention to us? So again, contact information down there, and it'll be on the final slide as well. Before I get too far into this, I realized my earlier session, my earrings kind of rattle on this, and I don't want to drive you guys nuts all for the next 15 minutes. So what is a graph database? Most of the time when you tell people, hey, I work for a graph database, or hey, we have a graph database product, this is what they think of. They think of charts. So really pretty pictures. Does it store dashboards? Does it store images? Whatever. These are not graphs, by the way. They're charts. There's a difference. But what we actually mean when we say graph is something more like this image on the right-hand side. So where we're breaking down the structures into individual entities, very small pieces of data, and saying, how do these pieces of data relate to one another? How are they connected to one another? At their core, all databases basically just take a structured set of data, hold them in a computer, and then one that you can typically interact with in a variety of ways. So you can get the data in and out in a variety of ways. Whether you're dealing with relational, NoSQL, graph, it really doesn't matter. All of these provide that same basic core functionality. What's different about graph is that it uses graph structures for semantic queries with nodes, edges, and properties to represent and store the data. That's okay if those terms don't mean anything to you. We're going to walk through each of this, and by the end of this, you'll understand this a lot better, I hope. So why would you even choose something like a graph database? What does it provide for you? What benefit can you get out of it? There's a variety of things around us now that are very, very connected. The world is increasingly becoming smaller and smaller, and we're becoming more and more connected. So when you talk about social media, social networks, they're becoming very close, even across the globe. We're very, very highly interactive. Companies and markets, history, industries, even technology stacks, very, very global. So these networks just continue to get smaller and smaller, or larger and larger, depending on how you look at it. And even our criminals, our fraudsters, and their behaviors and their patterns are very consistent across the board, no matter if you're looking at someplace small here or some major city here on the other side of the globe. I like this chart, not a graph, chart, that shows the different databases and what they're good at, and maybe what they're lacking just a little bit. The one nice thing about graphs is that they can excel to an extreme level of depth, an unusually high level of depth that many other databases just can't reach as well or as quickly or as efficiently. You notice that relational databases, they do pretty well on size, but they don't quite hit the depth that graphs do. But they do better on depth than some of these other guys. Key value stores there at the bottom right exceed very, very well on their size. They can handle massive amounts of data, but they can't go very well into a maximum amount of depth traversing those. So just looking at kind of the data model structures that are different. In a relational database, if you had an employee who worked in multiple departments, you would probably end up with this associative entity or join table, lookup table, however you wanted to define it, here in the middle, where you'd say, I want to know who Alice works for, what her departments are. So you would find Alice on the employees table, and then you'd go to this lookup table and say, for the ID of Alice, for the row of Alice, what all is she connected to in this other table for departments? And then you need to go look up these values and say, okay, these three are the departments that she works for. Where in graph, again, we're breaking down these structures and saying the individual piece, so I'm just finding Alice's node in the database, and saying follow the belongs to relationship and find out which departments are on the other end of that relationship. So it's only connected to the 3 that are related to her. There's no need to scan the entire table and look at all the rest of the departments to find that information. If you compare it to NoSQL databases, other NoSQL databases, we have a key value store up here and a document database down here. Basically, again, what you can see is it's breaking out that structure. You're on the left-hand side here, you have some sort of particular structure that's being connected and organized. But then on the right-hand side, we're basically in graph, you just break that into pieces and say, now how is each individual piece related to one another or to other pieces or other components or however you want to relate. So it's used for anything from internal applications, external applications. It's not just meant to, kind of just be customer facing. It has some valuable applications internally as well. So things like master data management, network and IT operations, fraud detection, knowledge bases, anything like that, as well as customer facing applications. So real-time recommendations, recommending products and services that your customers like based on their history, as well as graph-based search, and then identity and access management. So who has what role access? What resources should they be allowed to see and what resources shouldn't? So some of these are here. Social networks is probably the most common one that people think of when they hear the term graph. So Facebook, Twitter, anything where you're looking at people and who they're connected to. Very good use case for graph, as well as impact analysis. So something goes down or something happens. What all does that impact? Because what is it connected to? What's it related to? Recommendations I mentioned, logistics and routing. If you look at IT networks, they're very, or roads or anything else, they're very much based on point to point to point, and they're connected via roads or maps or connections of some sort. And so what is the best way to get through a network? That's something that's very good in graph. Access control, if you have access to this or if you have this particular role, what resources should you be allowed to see? Fraud analysis, if you have a particular user who's doing a fraudulent transaction, who are they connected to, or do they share a social security number with somebody else? That probably means there's a fraud ring there. There's something hidden that you wouldn't necessarily be able to see otherwise. So how do we actually go about using something like a graph database? We've got to see the value of it possibly. We kind of see the structure of it. Neo4j specifically, we use the property graph data model. There's a couple of other graph data models out there, but property graph is one of the big ones. And it's known for being whiteboard friendly. Basically, all this means is that it's easy to design and model with a direct representation of it. So if we were to take an example, Neo4j, we love all things the matrix. So you'll see a lot of our examples. We'll use terms from the matrix or characters from the matrix. But if we were to take a very simple graph, you'd probably sit down with your colleague at a whiteboard and you start drawing out, okay, here's the process, or here's kind of my data model, what we think is important to put together in this process. So we have our Matrix movie here. Lana Wachowski directed The Matrix. Hugo Weaving acted in The Matrix. But Lana Wachowski, Hugo Weaving were also involved in Cloud Atlas, and Tom Hanks acted in Cloud Atlas too. So we kind of draw this up. Okay, that looks pretty decent. You might kind of neaten it up a little bit, something to show, other people on your team or maybe your manager, hey, this is kind of what we think this process will look like, or what our data should look like. And then you might add some more details. So we're going to start categorizing. We have Cloud Atlas and The Matrix. We're going to categorize them as being movies, so kind of giving them a tag or a label. And then we have Lana, Hugo, Tom. They're all person nodes, so we're categorizing them as persons. But then we want to delineate that just a little bit more. Lana Wachowski is a director, so we're going to give her an extra tag there and say she's a person type of director, kind of. And then Hugo Weaving and Tom Hanks, they're both actors, so they do something different. And then when you have an actor acting in a particular movie, they might play a particular role. Could be multiple roles, like Christian Bale in Batman Begins plays both Bruce Wayne and Batman. That's two different characters. So you could have potentially an array list here of multiple characters, even if they're just playing themselves. So we'll kind of define that a little bit, give a bit more detail about when you have a combination of an actor with a particular movie, they're probably going to play some particular role. And then Lana down here directed both of these movies. And we'll add released properties, so the year that the movie was released on our movie nodes. We'll add a birth year to all of our person nodes. So kind of give some more details about our model. We think it looks pretty good, pretty accurate now. That's actually what it looks like in Neo4j. So notice how very, very similar that looks to that. Almost exact replica, a little bit neater. Our visualization tool is a little bit prettier. Now, somebody may ask, hey, I can't see the properties here. I can't see all the details. Really, this is just the way the visualization kind of sums it up, so you can get a high-level look. If you drill down into these nodes, it'll tell you all that information, all the properties, all the details about that. And then the colors are kind of color-coding your nodes. So your green are your movie nodes, and then your blue are your person nodes. So that's kind of nice, too. Okay, let's talk a little bit more about the data model. We kind of breezed through it. I mentioned a couple of terms, but let's actually look at how it is kind of compiled here. So we have two main components in the property graph data model, which is what Neo4j uses to structure its data. We have nodes and relationships. And then you can add a couple of extra components to kind of give more detail in labels and properties. So if we were to look at an example here, nodes basically represent the objects in the graph, and you can categorize them using labels, which we talked about with movie and actor and person. So in this example, we have 3 nodes. We have 2 of them are going to be person nodes. 1 of them is going to be a car node. So we're kind of categorizing them. 2 are going to be in one category, and this last one is going to be in the category of car, tagging it with car. Then you might add some relationships. So how are these nodes related to one another? How are they connected? What type of meaning do they have with one another? So you can relate nodes by type as well as by direction. So in this example, we've chosen this person has a loves relationship with this person, same vice versa, this person lives with that person, this person drives the car, this person owns the car. So you can have different types, different relationship types. That's what these are, to kind of define different kinds of relationships, different meanings. And then you can also specify a direction. So here we have love's relationship here and there. You could also say one single love's relationship. So there are some, with Neo4j, it's a bidirectional relationship. So therefore, you can store it just because this person loves this person doesn't mean they love them back. So you can store it vice versa in both directions. However, this person lives with this person implies that vice versa, this person lives with that one. So therefore, that's a bidirectional relationship. No matter which way you query the lives with relationship, Neo4j can retrieve both sides of that. So a little bit of a complication there, but kind of nice when you start querying, because then you don't have to understand the core data model underneath. Properties are basically just name-value pairs. You can put those on nodes as well as on relationships. So here we have name, born, and Twitter property. Notice here we only have the name and born, the birth date. We don't have the Twitter property. And that's because with Neo4j, you don't need to store null values. If you don't have that property, you just don't store it. There's no need to store null. So in a relational database, you might have an empty field for that person. You would have a column, and some values you would store in for Dan, for instance. You would have his Twitter handle, but then you wouldn't have ands. It would just be empty or null value there. In Neo4j, you just don't store that. You don't have it, you don't store it. And then you can also put properties on relationships. So this person has driven the car since a particular date. So the way we put data in and take it back out of Neo4j is typically with the Cypher query language, which is basically SQL that was designed for graph structure. So we took a lot of the things that SQL was very good at, the power and the capability there, and we just applied them basically to graph theory and to graph structure instead of tables and columns. So it's based on ASCII art, so it's very easy to read, very visual. So if we wanted to create this example of Dan loves Anne in our database, we'd start with create keyword, and then to create our nodes, we have parentheses here on either side that show the node. So notice if you kind of bring those parentheses together, all of a sudden you get the circle, which, guess what, is exactly how we visualize it in the graph. And so that's kind of the whole idea of Cypher, is that it's very visual and easy to read in nature. It models very closely to how we visualize the data. So these then are our two nodes. We have our person node, so this is our label or our category. And then we have a property of with a name value of Dan. And then we have our other node on the other side of type person with a property name and a value of Anne, which is basically what that shows. So we have our labels here at the beginning specified with a colon, and then our property inside the curly braces there. So those are our nodes. And then in the center, we have this loves relationship. So again, it looks very similar to the arrow that's specified here. So we're storing the Dan loves Anne in this direction in the database. And we're going to say there's a relationship type of loves. It could be anything. It could be likes. It could be lives with. It could be drives. It could be works with, works for, however you want to specify that. But this one, we're just saying there's a loves relationship from Dan to Anne there. Then if we wanted to return that out of the graph, so we just stored it inside Neo4j. Now, how do we want to find out who Dan loves? We know we have a node in there of Dan. We know he loves somebody, but we don't know who's on the other side of that. So you can write this query using match, which is basically like select for SQL. And then we know it's a person node. We know he has a name of Dan. And we know there's a loves relationship. But then we're just going to kind of put a variable in this other node because we don't know the details of the thing on the other side of this loves relationship. And then return that variable, and it'll return all those properties and details about Anne in this case. There's a variety of ways to import data into Neo4j. I'm going to actually walk through a demo here in just a second. So I'm going to walk you through my process and how I got some data into Neo4j, but there's a variety of ways to accomplish this. First off, you can write Cypher statements like we just did, where we created Dan and Anne in the relationship. You could also put all of these into a script and run the whole script, just like you can with SQL scripts and such. But there's some easier ways to do this. So if you have flat files, if you have CSV files, you can also use our load CSV tool, our Cypher functionality, basically. And that can handle small and medium-sized data sets. You can import local or online CSV files into the graph. That's pretty easy to do. You just need to specify the columns that you want to pull in from the CSV file and what you want that data to look like on the graph, because obviously you're going from a column and row format into a graph data structure. But that is used quite widely. Then we also have our ETL tool that takes data from a relational database. As long as you have a JDBC connection that you can connect to, you can use the ETL tool. But it imports relational data and helps you map it into a graph structure that you want. And then finally, APOC, which is our standard library. It's utility functions. They're up over 450 procedures and functions in that library right now. I wouldn't particularly want to use Neo4j without APOC. It's awesome. But I'll show some of those examples as well. So it handles a variety of things, anything from import to text manipulation to data cleanup to all kinds of transformations and all kinds of interesting things. So let's look at a couple. So I've kind of done a combination. I'm importing from a URL. So I absolutely love the Lord of the Rings movies. I have since I was a kid. And so what I thought I would do is I would try to find the data set, see if we could come up with anything valuable out of that data, anything interesting. And I was able to find the moviedb.org here. They have an API, and they did have some information on the Lord of the Rings. So I thought I'd just pull that in, just see if there was anything remotely interesting there. So I'm basically setting up a URL string that's basically the API URL here, and then I'm passing it into this APOC procedure. So apoc.load.json takes a JSON document or format, and then I just yield that back as an object and unwind that JSON structure. So I take all that nested data and kind of just loop through it and unwind that nesting. Then I pass that through and take this merge statement, which merge basically does a find or insert. So if it sees that this movie ID already exists in the database, it's going to just return that already existing, so you don't get duplicates. But if it doesn't find it, then it's going to insert it for me. So merge is very, very handy. Wonderful thing. I'm going to create movie nodes. So I've got a tag of movie with a movie ID property, and then an ID that's coming off of the API. So this results is here what I'm unwinding from my JSON there. And if it's going to create the node, then it's going to set all these properties. So a title, a review star, a poster path, etc. And then I had a couple of issues when I brought in the data that some of the release years for the movies ended up being empty strings. And those weren't really valuable when I started querying. In fact, it was causing some errors with some of my queries. So what I wanted to do is cleaned all my data out, re-imported some things, and I call another APOC procedure that says, do this when you find a certain scenario. So when the release date property coming off the API is an empty string, set release date to null. So don't set it at all. Remember, Neo4j doesn't store null values. Otherwise, we're going to convert it to a date format and store it as a property. So that's all that's going to do. Now, that just gets me my Lord of the Rings movies. I'm just hitting the main search for movies, and I'm searching for Lord of the Rings. Then I wanted to kind of import and kind of hydrate that model just a little bit and add a bit more detail about those movies. So if come to find out, they have some additional information about each individual movie. So if you go to the individual movie ID endpoint, it'll return information about characters and cast members and things like that. So I go back out, and for each one of these 3 movies that I already have in my Neo4j database, because for some reason if you hit the API and you got 50 movies, and then you went out to the API for each one of the 50 movies you got before, guess what? You might return 51 movies. Well, you don't have that extra movie in your database, and so now your data's out of sync. So what I ended up doing is going back to my database that I'd already loaded, said these are the values that I really want to add extra information to. So for each one of these movies, Fellowship of the Ring, The Two Towers, The Return of the King, from my Neo4j instance as movies, then I'm going to run this APOC procedure, which basically says I'm going to take this first Cypher procedure, which looks at the movies where the title is one of these 3, and then call the apoc.load.json back to the API and pull back the results for each one of those movies. So for each one that you find in this first Cypher statement, which will be all 3 of these, go back to the API and call the detail information for each one. And then again, I'm going to create cast members, and then create characters, and then set up the relationship. So a character will appear in a movie, and a cast member will play a character. So that's kind of my overall data model. Demo time. This is the best part. Okay, so let's swap here. And that might be, okay. So I first want to show a little bit of my data model, which I kind of explained when I talked about the import. But just to show, I don't know why this does this. It doesn't like me. Name. There we go. Okay. Much better. So this is kind of the high-level data model that I have. I have movies where characters appear in a movie and cast members play characters. So pretty simple data model, actually. Pretty simplistic, just 3 nodes, couple of different relationships. But we're going to find there's actually a really good amount of value out of this. So let's just return some data. So match. And we know any node type, basically. We know there's going to be a relationship of some sort. We only have 2 different kinds of relationships, but we're going to retrieve everything. And then return NR and N2. So this just says I need to return all the components of this. You could return only nodes. You could return only the relationships. But I want to return each component of this and just see what we get. Okay, quite large. Let's zoom out a little bit so we can see. So that's a decent amount of data. It's showing me 300. I think I could probably set that a little better, but let's see. Okay, there, much better. Okay, so that's still pretty cool. We can kind of see we have 3 movies here in the center in red, because our movie nodes are in red. And then you can kind of see we have some blue rings around them. Those are all the characters here. And then the cast members are in green. So you can kind of see some overlap. I know it's kind of hard to see with the zooming and all of that, but you can kind of see they kind of outline those in blue. But it's kind of hard to see anything at this level. You can kind of see some basic structure. Maybe there might be some interesting things. Hey, there's some overlap here. You've got some cast members that look like they're overlapping with characters between the movies. That might be something interesting to dig into. But again, it's really hard to see at this level. So let's kind of go back to basics, start really small. Let's just look at the movies that are in our database. So type movie and return all of our movies. And zoom out a little bit. So we get 13 nodes back. That's what shows up here. And that's all of this right here. And so we can kind of click on each one and drop down and look at the details. So this is The Making of the Lord of the Rings. That's the title of this one. So that's probably a documentary. We have The Hobbit. Ooh, that's on there. How did that get on there? Well, oh, wait a minute. This was made in 1977. So this is an older rendition of it. This isn't the newer trilogy that we're thinking of here. We have The Master of the Rings. That looks like a documentary. This really isn't telling us anything about the trilogy movies that I really care about. So let's kind of narrow down our focus just a little bit. Let's say we want to return. We know the movies were made. Were made after 2000. So we'll say where m dot release date is greater than a date of 2000. 01, and then return movie. Okay, that does a little better. We now have 9 nodes there up in the left-hand corner, you can see. So there's 9. There's creating the Lord of the Rings, okay. But we're still having to drive into each node and check the property and say, okay, when was this made? What does it do? What's the title? What are the details about it? What if we just wanted to see, okay, what are all my titles and all my release dates, just in a nice, pretty format? So we could actually return, instead of just returning the whole movie, we could return m.title and m.release date, like that. And this will give us, a little too zoomed in maybe, this will give us a nice neat list. So here's all of our movies there on the left-hand side. We have all of our release dates, so now we can at least kind of see this data a little better. We could even go so far as to say, okay, I want to order by m.release date in ascending order. I like descending better, typically. So now we have our latest released movie followed on down the list there, and you can kind of see if you just kind of scroll. We had our extended edition that got thrown in there for the Fellowship. We had a couple of documentaries, and there's the actual Fellowship down there. So there were a couple of releases in between that first and second movie. But again, it doesn't really tell us a whole lot of detail. And I really care about the trilogy movies. That's really what I want to focus in on, and we're still not wired down to those 3. So now let's be uber specific. Let's just add movie, where m.title, and we can add a list. So Lord of, these are really hard to type because they're so long. The Fellowship of the Ring, and then I'm going to copy paste that. The 2 Towers, and then finally the Return of the King. Okay, and then return M. Whoop. Yep, thank you. Excellent, you're catching my typos for me. Perfect. So now we end up with our 3 movies. Okay, that at least gets us wired down to the movies that we really care about. And we can dive into each one, of course, and check out all the details, the properties. You get the description, you get the poster, the reviews, etc. But where it starts to get interesting is where we start looking at relationships for these movies. So my absolute favorite of the trilogy is The Return of the King. So let's just look at, and I'm going to pull all this out and go with, actually, just looking at The Return of the King, we can do it this way. So title is Lord of the Rings. Okay, there we go. And then we want to see the relationships that are involved here. So we know we have movies that where we have characters that appear in the movie. So appear, and then we're going to have characters. Voila. And let's just return all of these pieces again. So we're returning our relationship and the characters. So now we get something that actually looks pretty cool. We've got some value starting to be seen here. So we have our Lord of the Rings movie there in the center, and then you can see this lovely ring of characters all around the outside. So this looks like quite a decent bunch of characters. You can already see some favorites here. We have Samwise Gamgee. There's Éowyn there. There's Éomer and Aragorn. All of these good characters. So you could start comparing, okay, across movies, is this an abnormally large cast size or character set that the kind of the plot follows, or is it unusually small? Or maybe with Peter Jackson directing, he's the director of all these movies. Does he stick to movies that typically have a larger character size or maybe a smaller character size? So even at this stage, even something this simple, you can do some analysis on it and really pull some interesting things out of this. But we want to go one step deeper. We want to look at, okay, we know cast members play particular characters. So let's add this extra relationship here in the middle. I'm just going to create another variable, R2, cast members played characters, and then we just need to add these two onto the end. So return all those pieces. And remember, this is just the Return of the King. So now you kind of get this ring. You kind of see those two rings there. So we have our movie here in the center, single movie. We have all of these characters that surround that movie. And then we have all of the cast members that play those characters. Now already, even though it's kind of a lot of data, your eye kind of is drawn to, hey, there's a lot of cast members that play this particular character. You might see some overlap here. We've got a couple of actors down here that play characters. So your eye kind of is automatically drawn to some of these things that seem like outliers. You normally expect, okay, you have a cast member, he plays a character that exists in a movie, but there's some other things that don't quite fit that expected pattern. So maybe we want to dive just a little bit deeper into this. And then if we look at across movies, so let's see, movie. I keep wanting to do that. It must be a typo thing my hands want to do today. So this was one thing I wanted to show earlier, and I didn't. The Fellowship of the Ring. And then do it again for the Two Towers. I tried to shortcut some, but these are long titles. And then finally, the Return of the King. So if we return a whole graph now, it makes a little bit more sense as movies. So basically, I'm just setting all of these values, and then I'm going to pass them into my query, where m.title in movies, return m. Wait, I need my relationships up here. Lovely. Okay, so r. Here's an character. Type character. Our relationship here of played with our cast members, and then return everything. Here we go. M, R, C, R2, and A. Perfect. Okay, now we've got it. So what I like to do with this with statement there at the beginning, if you have a list that's coming in of 10 movies, or if you have a list that's coming in of 50 movies, you don't necessarily want to muddy the waters of your query and by typing them all in a where statement down here. So what you can do with Neo4j with Cypher is you can specify this with clause that says, okay, all of these values, pass that into my query basically as kind of a parameter. And then you can check each one of those values, and it keeps your Cypher statement very concise. So it's just kind of a personal preference. You could do it either way you wanted, but I think it keeps that Cypher very clean. So this gives us back our graph here, and this is what we looked at kind of at the very beginning. So again, your eye's kind of drawn to some outlier information. It makes a little bit more sense to us now that we know kind of what we're looking at here with those circles of blue with the characters and then our cast members. But what starts getting interesting now is we already saw some overlap with Lord of the Rings. What happens if we look at specific overlap between movies? So we're going to even kind of trim this down just a little bit more. So with our 3 movies, there are some people who overlap. So maybe let's kind of dig in and see, do we have characters that are played by multiple actors? Or vice versa. We're going to check out first actors that play more than one character. So in that, we're going to add I think, everything here. So with that, and then where size of this would be character. Played multiple actors. Oops. Nope, vice versa. I always get these 2 mixed up. Very confusing. I like to do this one first. So character here. And basically, this is just saying, I want to look for the size of this pattern, which is cast member played character, and check if there's more than one. So I'm looking at a particular cast member and saying, okay, find all of the characters that they're related to and sum those up, aggregate them, and say, is it more than one? Where you have more than one, then we're going to look at those specifically. So we're ignoring everybody that just played a random, boring single character, right? All right, so this comes back a really interesting list. I'm going to kind of coordinate in chronological order, just because I'm that way. So here's our Lord of the Rings: The Fellowship. Here's our Return of the King. So at the bottom there. And then our Two Towers goes right in the middle. Okay, so this is a much more manageable data set. It's a little bit smaller, hopefully a little bit easier to see. I know the text is a bit small in there. But we can start seeing some interesting things out of here. So here's Peter Jackson, first off. Notice that he has a lot of relationships kind of diving into our movies. So we see Peter Jackson. He played an uncredited Corsair bosun here, there. And then he's got a Rohan soldier that he's also uncredited. And then he plays this character of Albert Drury in the first movie that's also uncredited. So he just kind of filled in some gaps. Now, whether he was like, oh, we need somebody on set, I'll just fill in that role, you don't even have to credit me, or whether he was like, yeah, I'd like to make a cameo movie in the movie and see how many people recognize me, even though I'm not in the credits, or who knows what the deal was with that. But it's kind of interesting still that he kind of inserts himself into each one of the movies. Also, what's interesting about these is you see Katie Jackson and Billy Jackson here. Those are Peter Jackson's children. So he's even rolled in the family deal here and said, I want my kids to kind of throw in different roles. Now, they mostly play some small roles. They have I think that's a hobbit. They've got a Rohan refugee child over here and just a regular child in the third movie. So reasonably small, kind of generic. But he still kind of involved them. Now, again, whether that's he didn't want to pay extras, and so it's like, yeah, just throw my kid in there, throw them through costuming. Who knows what his reasoning behind this was, but it still kind of gets those gears turning. It's like, okay, he's involving some unusual people here. One that I think is really super interesting. So as a high school student, as a college student, I absolutely loved these movies. I love them so much that I spent hours on the computer on websites looking up behind the scenes and different like oops and credits and how the making of the movies and the music and the sets and architecture and art and all this interesting stuff. So I knew quite a bit about the movies. But it's interesting what you find out when you plug this stuff into a graph database and go, I never knew that. I had no idea. One of those things is Craig Parker here, this actor who I've pulled out. So he plays Haldir, the elf, in the first and second movie. Now, what's interesting, he was my sister's favorite character, so that's kind of why I've zoomed in on this. He's a relatively small character. He's in the first and second movie. At the end of the second movie, he tragically dies in the great big battle. And then that's it for his character. He's done. There's no more Haldir, sadly. However, notice that Craig Parker has another character node that appears there in the third movie. So he does a couple of voices down here. He does the voice of Gothmog and he does the voice of Guritz. He's uncredited for at least the second one. Might be the first one too. So he's uncredited, but he appears in that third movie. Now, why in the world would Peter Jackson take somebody whose character's dead and long gone? Why would he rehire them for the last movie? It's not like he's trying to, go, oh, your character died halfway through the second movie, I'm going to throw you in as an extra. No, he brings him back for this third movie. Why would he do that? Maybe Craig Barker was hard up and needed a job. Maybe he needed some work. Maybe he's like, I know this guy. I've worked with him before. He's a really good actor. He's dependable. He's reliable. He'd be good in this. Throw him in and do some voices. Maybe he wanted to keep kind of his little intimate crowd throughout. So I've had these guys, 2 movies out of the series. Maybe I want to keep this same group and say, we worked all through the entire trilogy together. So who knows? But it starts those gears turning. Okay, he likes to kind of reuse people. Then you could look at even across Peter Jackson's movies. So all of the other things that he's done, King Kong and anything else he's directed, does he tend to reuse? Even across movies. So does he take people that he's worked with before in Lord of the Rings or other movies, and does he bring those across and say, I've worked with you before, I want you to work with another movie with me? So who knows? That's something interesting there. The other thing I do want to point out is there's some data cleanup stuff in this particular data set. So in the API, nothing's perfectly clean anyway, but we have Andy Serkis over here who, if you're familiar with the movie series, he does both Smeagol and Gollum. However, he's got 3 nodes here. And so you can see he plays Gollum and the Witch King of Angmar for the voice in the first one. He does Gollum, Snaga, and Mahur. The last 2 are voices in the second movie. And then he just does Gollum in the third movie. So you could probably clean this up a little bit, say, okay, all 3 of the Gollums throughout the entire movie series, those are all the same. We'll split on the slash, and we'll pull those out into separate characters and kind of clean that up a little bit. Maybe you want to categorize voices as being something totally separate or a different level of acting. And then the other thing I was going to mention is, Brad Dourif. So he plays Grima Wormtongue, appears in the second movie, also in the third movie, but you can see that this character says Grima Wormtongue Extended Edition. So they're the same character. You can merge those into a single node and kind of clean up that data. But again, this is everything that's coming straight from the API. So this is what I was handed. I just haven't done all the cleanup. But I do think it's important to show if you're getting your data sources from other places, you might have a little bit of cleanup and better working to do on some of that. So now we've seen some pretty cool things about looking at where you have cast members who will kind of fill in and play a lot of different roles. The next one, let's kind of swap this a little bit, and let's look at the characters who have multiple cast members involved. So these are going to be typically smaller roles because you're not going to take somebody like your lead character, like Aragorn or Eowyn or anything like that, and just throw another actor and say, okay, this is now this person. You'd have an uproar of people very upset that you changed the character or the actor. However, you're still going to find some interesting things here. So let's take a look. Again, smaller data set because we're expecting that you're not going to have as many characters that are generic, where you'll have multiple cast members kind of subbing in for them. 2 towers, and then there we go. Better. Okay, that fixes my OCD for now. So now we have all of our grouping there. We've got some nice clusters, smaller data set. Already you can kind of pull out, okay, here's Rohan Refugee. Uncredited, there's 4 people that kind of play that role. There's some across movies. So if you pull out, there's orcs here, and there's hero, orc, goblin, uruk. Again, those could all be split out to where they're much cleaner. But you have some overlap here. So you've got some that kind of play orcs and goblins and uruks. They also play hero orcs here. They also play just generic orcs in the final movie. And again, so you kind of see this overlap. He tends to kind of bring those people that maybe he's already used as extras before, fill them in the gaps in the next upcoming movies. So again, a common theme. One thing that's really, really interesting that I love to point out, my favorite thing of the whole data set. Again, I absolutely loved these movies. I knew all of the insides and outs. One other thing that I didn't know, I was a huge music lover as a kid. I played a lot of music. I played a lot of symphonies. My absolute favorite was film music. I loved film music. So I knew all the ins and outs of this too. what I found in the graph database is this node down here, Howard Shore, who played the drinking Rohan soldier. He's the film composer for the Lord of the Rings movies. What's a film composer appearing in the movie? What was Peter Jackson's motivation for taking the film composer out of his little corner cubicle or in front of the orchestra and throwing him on set? Yeah, go through costuming and makeup and appear in the film for me. Who knows? Again, he may have just really needed extras, or maybe he wanted to credit some of these people. You've been involved, you've done a huge amount of work. Come be involved and make a lasting impression on screen too. Who knows? But then it starts to get you thinking, if he's pulled the film composer in and put him on set, who else is he involved? Maybe your artists, maybe your architects, maybe your costume designers, maybe background, stunt doubles or cameramen. And then does this apply across all of his movies? So even not just The Lord of the Rings, does he do this for all of his projects? Or was this kind of a special one that was just near and dear to his heart and he wanted to include and kind of create this big family because they spent so long on the project? So it starts to get your mind kind of wondering, we don't know the motivations of why he did this stuff, but okay, if he pulled the film composer in, what else interesting has he done? So, and of course, other directors, I'm sure, have done similar things. But very, very cool to see this in the graph and to kind of realize these things that I really had no idea existed before. So with that, wrap up and just leave you with a couple of things. So you can do the exact same thing that I've done. You can download our Neo4j desktop application, which is a local instances of databases. You can create as many local instances as you like, spin them up, import data, or do your own analysis, or use tools and libraries to interact with that data. You can also, if you don't want to download anything, we have our Neo4j Sandbox offering, which is just basically instances spun up on the cloud that are temporary. They last up to 10 days, and so you can do your own kind of working with that and figuring out Cypher and importing data and analysis and stuff. But then, of course, you don't have to do any downloads. So if you're working with limited resources on a desktop. And then our guides are out there, so that'll walk you through a lot of the stuff that I've covered today, as well as helping you learn Cypher and doing the import stuff, so like load CSV and APOC, all of that documentation. And by the way, APOC is an open source library, so all of the code is out on GitHub for that too, as well as our Neo4j, that's also available on GitHub. And then we have a certification program, so if any of you are interested, you can take it as many times as you like, the certification, but it kind of gives you get free sticker, free t-shirt, all kinds of good, wonderful stuff, and it really helps you learn a lot of the basics of how Neo4j works and the structure of the database. So with that, again, feel free to reach out to me, Twitter, email, or after the session, and thank you very much for coming, and I'll see you guys soon.